Fourier series for a triangular waveform. So, what is the first step in this case? Again, the first step is to write a function.
Right.
Here you can see that either we start from minus pi to pi or 0 to 2 pi, the function shape is almost the same. So, let's take from here minus pi to pi. So, it means that here we have two functions. Minus pi to 0 we have one function, and then from 0 to pi we have another function. So it means that we have to write equation for this and we have to write equation for this. How I am going to write an equation for the first part?
Just take points.
Yeah, again the same thing. That I will end at y minus y1 equals to m into x minus x1. So the very first step is I need to find the slope, which is y1 minus y2 divided by y2 minus y1, x2 minus x1. So for the first function, what are the 2 points? Who will tell me the first point?
Minus p is 0.
So the point number 1 is minus pi and 0, and point number 2 is
0
v
0 and
v.
v. Very good. So it means that we have these 2 points from which we're going to find equation for the left hand side, and then for the other we will see. So it means that using these points I can easily find the slope. So m equals to, so okay, so this is y2, this is x2, this is x1, and this is y1. So y2 is v minus 0 divided by 0 minus pi. So v divided by pi is the slope, which makes sense. Why? Because this is rising, so slope must be positive. So that's why you can see that you have the slope of the line is v divided by pi. Now, continuing further to write the equation, so we will be using y minus y1 equals to m into x minus x1. So let's take a point. So let's take this point. So it would be 0 comma v. So it means that why I have taken 0 comma v, so that I don't need to play around, and it's easy to put 0 here. Then m is v by pi x minus v. Oh, sorry. This is 0 because this is x and this is y. So this is your x1 and this is your y1. So finally it is v by pi x plus v. So here x is theta, so the final equation would be v divided by pi theta plus v, which is our first equation. You can see that from minus pi to 0, from minus pi to 0, the function is Vm by pi omega t plus v. Why? Because the slope was positive. So now the same thing we have to do for the other line. Who will find the equation for this line? Now your point should be this and this. Please do this. Do find the equation for second line, which is downwards for this part. Find the equation the same way I have done. So do it on your notebooks.
So couldn't we just, because it's the same line but negative,
Yeah.
could we just do that?
Yeah.
The same thing, just a minus.
Yes, that's minus. We'll do the minus 4. Yeah. Okay, very good. So since the other line has slope, negative slope, so the only thing that will change in this equation is that the slope will become minus v and v by pi. If you want to solve in the same way, then your point would be this one, and the second point would be this one. And if you follow the same procedure, you will get the same equation. But from visual inspection, we can see that since it has a negative, I mean the lines, everything is safe. The only thing is that it is dropping, so then slope would be negative. So now use these equations and try to find A naught. Use these equations and find A naught. Start finding A naught.
You got it twice plus v. What's the difference? Because of the
Why is plus v?
yeah.
It's because when you substitute this point, you end up with the intercept of v.
What point?
Okay, so-
Substitute.
Basically, you know the
Yeah.
v over pi, that's the gradient, right?
Yeah.
Okay. The intercept is v.
Oh.
That's where we add a v.
Confusion? Any confusion?
Oh no.
Sure. Any confusion?
No confusion.
So
Understood how to write functions?
No confusion.
Not completely. So whenever we have graphs and we need to write equations, so the only key things are the points on the graph that we can use for it. That's why the very first step was to identify points. And this one designates the model. So since it is a line, so there are some equations of line that we can use. So this is one of the equation of line. One equation of line. So now to use this equation, we need to solve slope. So we know that slope equals to y2 minus y1. We have changed the y to respect to x.
you should do integration by
Now
parts.
y2, y1 being at the point. It's very important to start with.
Oh no.
Because
no,
a0,
no, no,
because
no, no.
a0 is
Yeah,
a
yeah, yeah, correct.
5 was the x-axis, y was the seemingly, right? And then on the top side, the x was 0, but the y was the dealer we can point at it. So dealer to x1, y1, and x2, y2. It means that I can do things here.
Yeah,
So y2 will be minus 0, and x2 is 0. So that x is 2 is 0, and x1 is 0. It will be minus. So you will see this is the right. Now we have found the slope. Now the next step is to use the slope in this equation. So it will be y minus y1 equals to 1 by 5. Now you can use any point from the graph because you will need these points, right? This can be anything. I can write them at x3, x4, and anything. So for this equation, I have used 0 and b. So if I use 0 and b here, I can write this x2. So if I use, this would be y minus b because y is b. We have I. X minus 0. Finally, this will be 3 by 5 x plus v. This is the equation. And since the x in this case is theta, so y equals to v by 5 theta. This was your first equation. So this value.
Oh.
And since we're talking about
What do you got this question?
This one. I was figuring out how he did it.
It's broken too.
Yeah.
Positive and negative.
No, I know that, but same for the limit. Like phi under
You get the
two,
same value on the
that,
graph.
Okay, okay.
it's the inverse of the derivative. Because if you derivate this,
You lose
the
one.
lose two and you come to this one.
Yep. It's added.
But
Yeah.
it took me a while. So yeah.
Did you have to write on the last line? You ran out of space.
No problem. Like again, this one is my third notebook since yesterday.
Is it? Wow.
In the first year I use one, second year I use one, third year another one. Yeah. Let's see. Okay. Function axis.
You want me to solve it?
Simple.
The A0 is fine.
Hmm?
The A0 is fine. I'm going to
What do you get? What was it? 0, right? The value for A0. It was.
if you understood.
Okay.
Now I'm going to see.
So we have f of theta this everyone agrees with, right? We have calculated two functions in two zones. So one was rising, so that's why you can see that the slope in the equation is positive, rest is the same. The other equation was exactly the same, and the only thing is that you have a negative slope. Now the thing was that we need to find A naught. So A naught is 1 by 2 pi minus pi 2 pi f of theta d theta. So 1 by 2 pi, now we need to break the integral because the function is in two parts. So the first is minus pi to 0 d theta, and the second one is 0 to pi d theta, right? What will go here?
Let's go with P over
What I should put here?
P over theta.
Yes, so v over pi
Pi
theta plus v will come here, and then
C over pi.
minus b over pi theta plus v.
P is
Always try to put these brackets. If you would avoid bracket just for maybe speeding calculation, you will make a mistake. Okay, so it means that until this point we are good. There is no constant that we need to take out at the moment. So the only thing is that here you can see now you have two integrals, this plus this, and this. It means that inside integral you have two integrals, right? Now let's solve them. So it would be 1 over 2 pi. If I apply integration on here, since there are some, so it's not a problem, but then what I can do is minus pi to 0, b by pi theta d theta plus minus phi 0 v d theta. This is what I can do, right? Because these are just adding with each other. Similarly, for this side is integral 0 to pi minus b by pi theta plus 0 to pi b d theta. Here d theta as well.
Is the answer V by 2? V by 2.
Yes. Okay. So it's mean that we have to solve these integrals now. So let's do that. So it would be 1 by 2 pi. So you know that v by pi is constant, right?
Yep.
So the only thing here is theta for which integration apply. What is integration for theta?
Theta squared over 2.
Cos. What?
Theta
What is
square
it?
of 2 under
Theta
Squared over 2.
theta
Under
squared,
two.
right?
Yes, correct.
Always try to relate this with x, so x squared by 2. So this will be v by pi, which is constant for theta equal v, theta squared by 2, and limits are minus pi to 0. What will happen here?
Isn't it just v theta?
V theta, right? Because we will take v outside, inside is 1, and integration of 1 is theta. Now coming toward this side, more or less the same thing. Theta squared by 2, 0 to pi plus v theta 0 to pi. Now we need to apply limits. So in applying limits, you can see that if I am going to apply upper limit, it would be 0. Similarly, in this case, upper limit is 0. So 1 by 2 pi. So v by pi 0 minus true. So I simply I need to apply limit. I can simply take v by 2 pi, and the only limit applies on theta square, so that's why upper limit is 0 and lower limit is minus pi. And since it's square, so minus pi would become pi, and it would be pi square, right? Any confusion on this?
No.
Now, the next thing is we need to apply the same limits here, so upper limit is 0, and lower limit here it would be minus b pi. Why? Because upper limit is 0, lower limit in the place of theta I would put minus pi, and there is another minus outside. Same goes here, v divided by 2 pi, inside it would be pi square minus 0, because here lower limit is 0 and upper limit is pi. And when I come here, it would be v pi minus 0. So it means that now this is 0, this part is 0, this part is 0, this part is 0. I can easily simplify them. So if I go further, this is 1 by 2 pi. This is v divided by 2 pi into pi square. And this is, so minus, and this is v pi. So you can see that here this was 0. So v minus v divided by 2 pi into pi square. So I can, pi square would be cancelled with pi. So this would be v pi divided by 2. This is minus v pi divided by 2 plus v pi. And similarly, if I come here, again here it would be cancelled, so it would be minus v divided by pi would be on top plus v pi. right? So finally, if I solve them, so this is v pi and this is half of v pi. So ultimately this would be 1 by 2 v pi. So if I bring it here, so it would be finally 1 by 2 pi into v pi by 2, and similarly again here it would be plus v pi by 2. So finally it will be 1 by 2 pi into v pi, pi cancel and v divided by 2. Any confusion on this?
Where did the minus go?
What minus?
On the last row.
These minus?
Yep.
So if you solve them, take the LCM 2 will go here.
No, I'm saying, you know how,
Which minus you're saying?
that term minus v, is that pi squared or just pi?
This one.
Okay.
This is pi square, right?
Okay, okay.
You cancel out.
So finally it comes here, so this is v pi, so if I take the LCM, so 2 will be multiplied with here,
Hmm.
and 2 minus 1, 1 and divided by 2. Indirectly I can say that 1 is 0.5 and the other is 1. So ultimately you will be having 0.5.
Ah, okay.
I mean half is subtracted from full. Because they both have same thing, only thing is this is 1 and this is 0.5. Okay. So any question on this? No questions? You don't understand or you understood?
Understood.
fully?
No, it's fine. No, it's fine.
This whole is good muscle exercise.
Well, why you using one for trigonometry and the other one exponential? Is it two different way to find the variable?
Yes, so after this we will come to exponential and we'll see what is the difference.
Okay, applying the same formulas, right? Or,
Slightly different formulas,
yeah.
but we'll take trigonometric Fourier series and we'll convert it into exponential. And we will tell the significance there, what is.
Which one's better than?
Yeah, so exponential would be, I mean both of them they have their own significance, but if I roughly tell you in here you have seen that you start from 0 to infinity, right? So you have 0, 1, 2, 3, but in exponential you will also be having negative frequencies. So if we want to analyze negative frequencies, then it will come
That's
exponential.
it.
Okay. One important thing here, you can see that this function is symmetric about x-axis. You can see, if normally to check the symmetry, you either see on x-axis or y-axis. So if this is my x-axis, so this is reflected around the x-axis. So it means that this is symmetric around x-axis, whereas the previous function like square wave, that was symmetric around y-axis. So the function which is symmetric around x-axis is called even function. For even function, we don't have bn. Like our function, we don't have a0 and an, so for even function, we don't have bn. So that's why bn is 0, however, we do have a0, and we'll be finding now an. Okay, so to find an, we know that what is the formula. So the formula for an is the only, in the previous case you were simply integrating function, in this case you have to integrate function by multiplying it with cosine of n theta. So now this is slightly trickier part, right? Because previously you were having only one function which was theta, but now you will be having theta with another function. So it means that here you will be needing integration by parts. So start attempting it and then I will also solve for you, but try to attempt it yourself. So the very first step, split the integrals, write the two functions. Then the next step would be, since you have two, so multiply cos with both of them. Then within each you will be having two integrals. And then try solving one by one. One trick here is that once you split these, you know that this cos will go with this, cos will go again with this. Same cos will go here and cos will go here. It means that overall you see that you will have one integral with cosine only, another integral with cosine with theta, whereas the other is constant. So it's very useful that you solve it separately. You solve this separately. So when I solve this, I know this sine theta by n. And when I solve this integration by part, you can do that. You will see theta taking theta as first function and this is a second function. You will get this. Once you have this, simply put them in all the places. So in this way, it will be very easy. You see, after solving them separately, I simply put everywhere here all and it was very easy to get them.
I think there was a similar question with the tutorial. Yeah,
Oh yes.
yeah.
Did you get to this step? Anyone did this step?
Oh, don't type. Right.
Let's solve it. So an is 1 by 5 b. Now, the very first step is to split integrals. So 0 to minus pi to 0. This was function multiplied by cos of n theta. This was first part, and then the second part is 0 to pi minus b by pi theta cosine of n theta. So the first part is done. We have put function in the equation as per their limits. Now moving towards the second part. So if you focus on this portion, it is just like you are, for example, you have x and inside you have a plus b. So it would be xa,
Yeah, the form.
xb. So it will be multiplied with the both things. So a n equals to 1 by pi, and it would be v by pi theta cos of n theta, and then the second thing would be v cos of n theta d theta, and this is limit minus pi to 0, and this is minus pi to 0. Right? That means that I have done nothing, just that simply opened these brackets and separated the two functions because they were just adding up. So now there are two integrals inside. Now the same goes for the other side. Is it would be 0 to pi minus b by pi theta cos of n theta d theta plus 0 to pi b cos of n theta d theta, and so it means that overall now we have this integral similarly same for the other side, because this by pi is constant, v is constant, minus v by pi is constant, v is constant. So it means that overall I need to solve this integral and then the whole thing is done. So it means that I can solve these integrals separately. So I know that cos of n theta d theta is how, what is integral for cos? Sine. So it would be sine of n theta divided by n. So it means that the first part is done. One integral is found. Now we will move to the other integral because that one is critical. So theta cos of n theta d theta. This will be solved by integration by parts. So this portion would be integration by parts. So I need to choose first and second functions.
Finish here.
Is it next class?
Yeah.
What time?
12 o'clock. Data for decision making.
Okay. Probably we need to move. Okay.
Okay, take your time.
Yeah, we are moving a bit. Yes. Okay, so it means that we, in this case, u is the first one, and this is v because we choose simplicity. So first into integral of second minus theta bar right. This is how integration by parts work.
Yeah, use the formula. UVs.
Yes, and finally this would be, we know that for cosine the integration is sine n theta by n minus, this would be 1, and for this the integration is sine n theta by n. And if I further go, this would become theta sine n theta by n minus 1 by n, and again for sine this will become plus and cos of n theta by n square. This is what I written in the slide as well. Because finally from here you have to take another integral for sine, and for sine the integral is minus cosine, so minus minus will become plus, and 1n is here, and then the next integral again there would be another n, so it will come to n square. So it means that these two formulas were critical, and once we have calculated these two formulas, we can put them back into equation of an, and we will get our output. Okay. So one thing you can see is that I can take v common from all of them. So an is v by pi. Inside, for here it was 1 by pi, and cosine was sine n theta by n, and the limit was minus pi to 0. Similarly, for this portion, since it was integration by parts, so this one is the integration by parts. So this is 1 by pi, and inside this was theta sine of n theta divided by n plus 1 by n square cos of n theta. Yes, and here we have limit minus pi to 0. Same goes for this one, which is sine n theta by n, and the limit is minus pi to 0. So this was for the first integral. Integration by parts comes here, for this thing it comes here. And we need to do same for the other portion. So this would be minus 1 by 5 inside theta sine of n theta by n plus 1 by n square cos of n theta minus 5 is 0 plus sine of n theta by n. Yeah, it's just finished. Give me 1 minute.
you're finishing?
Yeah,
Okay,
1 minute.
we are meant to be starting 5 minutes ago.
Okay, sure. So it means that we have this equation, once we calculate it for separate, then we can put everything in this equation, and the rest we will do it in the lab.